For decades, geologists believed they had mapped every major volcanic threat in the Pacific Northwest. But in early 2025, a new discovery has shattered that illusion. Deep beneath the surface of Washington state, a colossal magma corridor has been detected not under a single volcano, but stretching across hundreds of miles like a hidden artery of fire. What scientists uncovered is not just unusual, it's terrifying. This isn't a future threat, it's moving, it's growing. And it's already affecting the land above. In this video, we'll uncover what they found, why it's so dangerous, and what it could mean for millions living in its shadow. One, a groundbreaking discovery in geology. In early 2025, scientists from the University of Washington and the U.S. Geological Survey (USGS) released findings that sent shockwaves through the scientific community. Using advanced 3D seismic tomography, researchers uncovered a massive, previously unknown magma corridor running beneath the Cascade Mountains, stretching from Mount Rainier all the way into western Idaho. This underground structure is not a single magma chamber, as seen in typical volcanoes, but a dynamic network of molten rock, constantly shifting and flowing through the Earth's crust. What makes this discovery especially terrifying is the scale and mobility of the magma corridor. It measures over 400 kilometers in length, with segments estimated to be as deep as 30 kilometers below the surface. Unlike Yellowstone's stationary supervolcano, this system appears to move like a subterranean river of fire. Seismic sensors recorded low-frequency tremors that suggested internal pressure fluctuations, even though no eruptions have occurred yet. Dr. Mark Hollis, lead volcanologist on the team, stated, "This is not a dormant system, it's alive and evolving beneath our feet." For decades, scientists believed the Cascadia region was geologically stable, outside of major faults. Now, that assumption has been shattered. What lies beneath Washington may not be a dormant threat, it may be an awakening force. Two, it's not about one volcano, it's the whole system. In past volcanic disasters, the threat typically stemmed from a single, identifiable mountain. Think Mount St. Helens in 1980, or the closely monitored Yellowstone supervolcano. These systems have one thing in common. They are fixed points, where magma builds up and erupts when pressure crosses the threshold. But the magma corridor beneath Washington completely breaks this traditional model. According to geologists, the newly discovered magma system isn't sitting quietly beneath a single volcano. Instead, it exists as a massive corridor of molten rock, stretching hundreds of kilometers, connecting multiple regions, and constantly shifting. It has no central crater, no clear seismic epicenter. Yet, pressure is rising in multiple areas at once, creating deep tremors invisible to the naked eye. As one expert put it, it's like a serpent of fire crawling beneath the earth. You don't know where it'll rise, but it's tightening the crust from below, bit by bit. Why is this system more dangerous than a traditional volcano? First, distributed threat. Magma may erupt from several locations simultaneously, not just from one main vent, making eruption prediction almost impossible. Second, mobility. This is a moving system. Its constant underground shift renders current hazard maps obsolete. Third, unreliable warnings. Early warning systems are designed to monitor specific sites. With this system, warning signs are scattered, making emergency response more complicated. Fourth, large-scale consequences. A chain eruption from this corridor could lead to ash fall across multiple states, temporary climate shifts, disrupted transportation, agriculture, and public health systems. This is a geological ecosystem, not just molten rock. The magma corridor behaves less like a static hazard and more like a living entity. It pulses, it shifts, it reacts. We are witnessing an ancient force slowly awakening beneath our feet. And this time, it's not from a mountain we know, it's from the very ground we walk on. Three, warning signs have already begun. One of the most terrifying things about the Washington Magma Corridor is this. It's not dormant, it's reacting, and the ground is starting to respond. Since late 2024, scientists and residents across the Pacific Northwest, especially in Washington and Oregon, have reported a series of unusual phenomena. At first, these events were dismissed as natural flukes. But over time, patterns emerged. They were all centered around key hot zones that matched the newly discovered magma corridor. Unusual deep seismic tremors. Seismic sensors detected low-frequency microquakes coming from 25 to 30 kilometers deep underground. These tremors are too weak to be felt by humans, but their frequency is increasing steadily. This kind of seismic activity often appears just before magma begins to rise, building pressure beneath the Earth's crust. Rising levels of sulfur and CO. Air monitors near areas like Yakima and Spokane have detected rising levels of sulfur dioxide (SO) and carbon dioxide (CO). These gases are typically released when magma is approaching the surface. Local residents have reported shortness of breath, eye irritation, and even mild nausea in low-lying areas. Ground temperature increases. At geothermal hotspots, surface temperatures have risen by 1.5 degrees Celsius to 3 degrees Celsius over just a few weeks, with no significant weather changes. In some areas, light steam is venting through minor surface cracks, a clear sign of subsurface heating and pressure. Ground deformation detected by GPS. Geological GPS stations have picked up slight but consistent ground uplift in multiple regions, about 2 to 5 millimeters per month. This is a classic signal that magma is pushing upward, like steam swelling a sealed container. This is no longer hypothetical, it's pre-eruption behavior. Scientists now classify the region's activity as pre-eruptive, meaning we are entering the early stages of a potential volcanic event. While no exact timeline is confirmed, what's clear is this. These signs closely resemble the early warning indicators seen before the 1980 eruption of Mount St. Helens. The difference now, it's deeper, it's broader, and it's happening in multiple locations. The Earth doesn't lie, it's signaling us. The question is, are we listening in time? Dr. Maya Granger, seismologist, USGS. Is history repeating itself? 1980, a warning ignored. On May 18, 1980, Mount St. Helens in Washington state erupted after weeks of seismic tremors and geological unrest. The eruption destroyed over 230 square miles of forest, killed 57 people, and left behind a massive crater, with ashfall covering much of the Pacific Northwest. But the real tragedy wasn't the eruption itself. It was the fact that warnings were given and not taken seriously until it was too late. 2025, a familiar pattern, but far more alarming. Now, with the discovery of the Washington Magma Corridor, many scientists believe we are facing a repeating scenario, but this time, it's larger, more complex, and far less predictable. Chilling similarities include: both began with minor, seemingly harmless seismic activity. Both showed increases in sulfur gas emissions, ground temperature, and surface deformation. Both are located within the Cascadia region, one of the most geologically volatile zones in the US. But this time, the differences are more concerning. Mount St. Helens was a visible volcano. The magma corridor is a hidden, moving underground system with no central crater. St. Helens gave visual cues: smoke, cracks, earthquakes. The corridor gives silent warnings via deep tremors, GPS shifts, and trace gas fluctuations. 1980. One eruption point. 2025. Potential for multiple eruption points, spreading across vast distances, possibly over days or weeks. Historical lessons. Listen to the Earth before it screams. Experts warn that if we repeat the same mistake from 1980, dismissing the early warning signs, the outcome this time could be exponentially worse. There are no second chances when a system like this erupts. Because it won't erupt in one place, it could erupt in many. Dr. Richard Holloway, volcanic historian. Five, a supervolcano in the making. A supervolcano is not just a large volcanic eruption. It is a rare geological phenomenon in which over 1,000 cubic kilometer of material is ejected in a single event, triggering global climate shifts, massive ecological disruption, and potentially threatening modern civilization. Only a few such events have been identified in history. Most notably, Toba, Indonesia 74,000 years ago. Yellowstone, USA 640,000 years ago. Does Washington's magma corridor fit the pattern? According to scientists, the newly discovered magma system beneath Washington shows structural similarities to ancient supervolcanoes. It is a complex, branching network, not a single magma chamber. It exists at great depth, with signs of potentially massive magma volume. It exhibits signs of increasing underground pressure, spreading in multiple directions. But what makes it even more dangerous is this. It's not stationary, it's moving, and that changes everything. What do computer simulations suggest? Modeling by research institutions in the US and Europe shows that if the magma corridor were to trigger a chain eruption, the consequences could include widespread crustal collapse, forming vents stretching for tens of kilometers, ash plumes reaching 30 to 40 kilometers into the atmosphere, darkening skies across western North America for weeks, reduced sunlight and falling global temperatures, affecting agriculture worldwide, continental-scale seismic waves, damaging infrastructure across major urban centers. Realistic scenario or scientific speculation. Currently, there is no definitive proof that Washington's magma corridor will evolve into a supervolcano, however. If you look at the early stages of every known supervolcano in history, they look a lot like what's happening here. Dr. Fiona Clark, European Volcanology Institute. The question may no longer be will it erupt, but rather, what year are we in, of its formation cycle, and is anyone listening before it's too late? Six, what's being done now? Scientists are taking action, but is it enough? Following the revelation of the Washington magma corridor, geological institutions and government agencies immediately mobilized. However, time is not on our side, and the magnitude of this underground system presents challenges we've never faced before. Expanding the geosensor network. USGS and major universities have deployed hundreds of seismometers to detect microtremors deep underground, high-precision GPS sensors to monitor surface deformation down to millimeters, gas detectors to measure increases in sulfur dioxide and carbon dioxide CO near active zones. Yet coverage is still concentrated in limited areas, leaving rural and remote zones vulnerable and under-monitored. Satellite surveillance from space. Satellite data in SAR is used to detect real-time surface elevation changes. Thermal imaging from orbit tracks abnormal heat signatures, even at night or through forest cover. However, analyzing this data requires time and advanced computing resources, which may delay actionable responses. Emergency response models are in development. Agencies like FEMA are currently building chain eruption simulation models to identify danger zones and evacuation paths, contingency plans to evacuate hundreds of thousands if eruption signs become more apparent. Integrated early warning systems push through phones, radio, and social media. But experts admit full readiness could take years while magma is already on the move. Government silence, caution, or cover-up. Many local residents and independent journalists are asking, why hasn't there been a public warning? Is the government downplaying the risk to avoid panic? Leaked internal documents suggest that multiple closed-door meetings have occurred between officials and geologists, but no press conference has been held. Just like before Mount St. Helens, no one wanted to cause alarm. Until it was already too late, anonymous scientist from the monitoring team. We're doing something, but are we doing enough? Yes, initial steps are underway, but against a mobile, multi-point, and unpredictable magma system, our current efforts may still be too little and too late. Seven. Conclusion. A terrifying secret beneath our feet. We are living above a machine no one can control. The magma corridor beneath Washington is no longer a theory, it's a real geological entity, and it's alive, breathing, and in motion. Unlike traditional volcanoes, visible, measurable, and somewhat predictable, this corridor is an invisible, ever-shifting network, and it has the potential to erupt from multiple points simultaneously. This is not just a threat, it's a system poised to wake up. Pressure is building, tremors are spreading. The ground is shifting, and the ash, it could be just a few tremors away from darkening our skies. Silence doesn't keep us safe. The lack of public warnings, delayed media coverage, and cautious government response mean that most people aren't prepared, and many still don't realize that the clock may already be ticking. The final question is no longer if, but rather when, where, and will we be ready in time to respond? There are things deep beneath the earth we've never touched, but that doesn't mean they aren't moving. Finally, the Washington Magma Corridor is not science fiction, it is a scientific reality unfolding beneath our feet, one tremor at a time, one silent shift at a time. And while no one can say with certainty whether it will erupt tomorrow, next month, or 10 years from now, one thing is clear: it is alive. In a world overwhelmed by speed, headlines, and momentary fears, we often forget that the greatest threat may not come from above but from directly beneath us. Observe, listen, and above all, do not stay silent. Because when the earth starts to speak, we may not have much time left to ask questions. Do you believe governments are hiding the full truth about this magma corridor? Drop your thoughts below.